this video, we are going to discuss how to convert a galvanometer into an ammeter. When galvanometer is used to measure current in a circuit, then it is called as ammeter. In order to measure current in a circuit, galvanometer is to be connected in series with the circuit. But by connecting galvanometer in series with the circuit, following problems arises. Galvanometer is having its own resistance, that is capital G. By connecting galvanometer in series with the circuit, the total resistance of the circuit will increase, which will reduce the actual value of current, and galvanometer measures this wrong value. So, some arrangement is to be made to reduce this resistance. Next, the galvanometer is very sensitive and it gives full scale deflection for very small value of current. So, we cannot measure higher magnitudes of current. And galvanometer coil is very delicate and can be damaged if excess value of current is flowing through the galvanometer. Some arrangement is to be made to overcome all these mentioned problems. So, in order to overcome these problems, a low resistance is connected in parallel with moving coil galvanometer, which is called shunt. The instrument scale is then calibrated to read directly the total current. Such an instrument used to measure current is called an ammeter. So, now let us discuss the functions of shunt resistance. First, it reduces the effective resistance of an ammeter. Second, it increases the range of ammeter. Third, it provides alternative path for excess current to pass and thus protect the galvanometer from damage. An ideal ammeter has zero resistance, but real ammeter have finite and small resistance. Thus, simply by connecting low value shunt resistance in parallel with a galvanometer, we have resolved all mentioned problems. In this diagram, we can see a low value shunt resistance capital S is connected in parallel with a galvanometer of resistance capital G. Now, let capital I is the value of current flowing through the circuit, which is to be measured. This current I, when reaches at point A, it gets divided into two parts. One part which is flowing through the galvanometer is called as Ig, whereas the other part which is flowing through the shunt is called as Is. These currents reaches at point B and gives the total current as I. Let Ig be the current flowing through the galvanometer, for which the galvanometer shows full scale deflection, and Is is the value of current flowing through the shunt. Therefore, we can write I is equal to Ig plus Is. Let this equation as equation 1. But potential difference across galvanometer is equal to potential difference across the shunt, because galvanometer and shunt are connected in parallel. Therefore, we can write Ig into G is equal to Is into S. But we know that Is is equal to I minus Ig. Therefore, we get Ig into G is equal to I minus Ig into S. By rearranging the terms, we get S is equal to Ig upon I minus Ig into G. This expression gives the value of shunt resistance that should be connected in parallel with moving coil galvanometer so as to convert it into an ammeter.